Hi, welcome you all again in this next video, which is memory management of arrays in Java, right? But how actually arrays are dealt in Java and backend. So let's see, whenever I write a statement like this, int arr is equals to new, yeah, 30, right? So it's actually an array which can contain 30 integers, which can contain up to 30 integers. So whenever I write this statement, what happens that there are two types of memories in Java. The first one is called stack. This one is called stack. And the next one here, it's called heap. So when I write a statement like this, then a variable of name ARR is a variable of name ARR is actually allocated here, ARR on stack, right? Let's write this one is stack and this one is heap. And a memory which is actually equivalent to 30 integers, and it is actually continuous, right? Array is a continuous block of memory. It's not distributed here and there. It's one continuous block of memory. So a 30 block of space is allocated here, which can actually be fetched by the name ARR, right? So ARR is actually pointing to this. But how it will reach it? How it will actually reach this memory? So the base address, that is address of the zeroth element. Suppose it's 4K. It's not really 4K. It can be anything. It's an address. So suppose it's 4K. Then 4K will be stored here. That is address of the zeroth element. Now, whenever I write something like ARR of 0, how Java actually interprets this is 4K of 0. That is a memory which is 0 integers away from 4K. That is the 4K itself, right? 0 integers away from 4K is the 4K itself. So suppose the value here was 10, 20, 30, 40, something like that. So it will return me 10. If I write ARR of 2, then it will mean 8 bytes because 2 integers, right? 2 integers away from 4K. 4K of 2 will be 2 integers away from 4K. That is 8 bytes away. That will be 4K08, which will be 0, 1, 2, 3, this memory. The address of this memory should be 4K08 and it will return me 30. So I hope you know how actually Java is dealing with arrays at this moment. Let's see some edge cases or some interesting cases basically. Suppose I have this array int arr is equals to new int, and let's make the size 3 only. Okay. And I initialize the values of 0 as arr of 0 is equals to 10. Let's make it 30 and equals to 8. Okay. So let's suppose I had these values filled in arr. Let's try to print arr. I know it's nothing special. You know the output already. This is called for each loop. I hope you know this, and if you don't, there should be a short video on our channel only. That how actually it works is that this array will contain every value from ARR. That on first it will contain ARR of 0, then after that ARR of 1, then after that array of 2, and what we'll be doing is printing those values. Okay, let's print it. I and this twice. Let's see if I haven't made a typo, it should be running, right? Okay, so it's showing 10, 15, and 30. Okay, so there is nothing special in that. Now, let's declare one more array. ARR of suppose 2 is equals to ARR. Now, at this moment, I have equated it to ARR, right? I have equated it to ARR. That means all the values from ARR will be equivalent to ARR 2 now. That is ARR of 2 of 1 will be 10 of sorry, at 0th index it should be 10, at 1st index it should be 15, and at 2nd index it should be 30. Just same as ARR basically. Now, let's try to print it for safety. Okay. Just make it ARR of See what happens. Wait, yeah. So up to this point, it was ARR, and after that, it's ARR of 2. And for a better view, let me put a print statement here. Okay. So this was easy up till then. Now, what I'll do is I'll make some changes in ARR of 2, right? ARR of 2. Let's see. Yeah, 10, 15, 30, 10, 15, 30. The later one was ARR 2 and the first one was ARR. Let's make some changes in ARR of 2. Let's say ARR of 2 of 1 instead of 15, it should be 150. Okay. Now I'll print ARR of 1 and ARR of 2 again. Okay. Okay. So this line will print ARR, right? This line will print ARR of 2. Let's try to run it. And let's guess the output perhaps. Let's guess the output. Because I have made changes in ARR of 2, that is this ARR 2, it should not be reflected in ARR 1, right? So ARR 1 should be 10, 15, and 30, and ARR 2 should be 10, 150, and 30. Let's check if it's the case. Well, they both of them became 150, and that's actually quite unexpected if you don't already know why it's happening. So to understand that this behavior of Java, we need to understand that how Java is actually managed under memory. So let's wipe this out. So when I wrote this statement, ARR of 2 is equals to ARR. What happened was that a variable, this was ARR, a variable of name ARR of 2 was created on stack. On top of that, it held the same address as ARR, and it was pointing to the exact same spot. So whatever changes I make here, whether using ARR2 or ARR, whatever changes I make in here, so they will actually be reflected in ARR also, right? If I make the changes using ARR2, they will be reflected in ARR because they are pointing to the same memory, right? As they are pointing to the same memory, everything that is fetched will be from the same place. So every change will also be reflected to that place. So I hope this was clear. But in case of primitive data structures, such as if I would have write int a is equals to 5, there is no use of heap happening. There will be a variable a and the value stored will stay at stack only. There will be no reference or anything allocated at heap. The value will stay at stack only. So this is the basic difference of memory management in primitive, that is int, and non-primitive, that is array type of data structures. So I hope it was clear enough, and if it is not, you can always rewind the video. So I hope you liked the video. Thank you very much for watching. Kindly press that like button and subscribe to our channel.